Good everyone. Good everyone. This is Math Intellectuals Tutorials, and today we are going to be looking at differentiation under calculus. Now, before we commence, don't forget to like and subscribe to this video. Now, let's look at this. Now, you have differentiation, which is the topic we are obviously treating today. Now, what is a derivative? Let's start with the fundamental or the foundation of differentiation. What is derivative? Derivative is the rate of change in the function at that point. The rate of change in the function at that point. That is, you must have a function, and then the rate of change of that function at a certain point is what we call the derivative. Are you getting it now? Now let's look at some functions here. Now let's look at this. This is a function, just like a quadratic function. Now this is a function, and you have a point A. Now if f of x is increasing at A, then its derivative is positive at that point. Now derivative rate of change of a function at a given point. Now at A, if f of x is what? F of x is this graph, is this curve. If f of x is increasing, then the derivative will also be increasing. Are you there now? Do you get now? That's why I say derivative is the rate of change of a function at a given point. Now if the function is decreasing, now let's look at, if the function is decreasing, then the derivative will also be decreasing, because when the function is decreasing, that means the rate of change between this place and this side, or between 2 points here, because the rate of change is decreasing, or because the function is decreasing, then we can say that the derivative is also decreasing. Is it clear now? Alright, so now when we say that the derivative is decreasing, or the derivative is maybe positive at a point, now look at it, you say that then its derivative is positive at that point, or at the point. Now which is also mean that the slope of the tangent line is positive at that point. That is, we can interchange the derivative of a function with the slope of tangent. Is it there? Are you there now? So now this is like a tangent, and then the slope of this tangent can also be referred as the derivative of that function. Is it clear now? Now let's look at this also. You have f of s is decreasing. I've already explained this. Now let's now move forward to another part of the lesson. Now let's look at this. I'm just trying to give more explanation, more details about the basics of differentiation, so you can understand the simple nitty-gritty concept of differentiation, so not just the calculation. So now let's look at another function. Now looking at this function f of x is a function f of x. Now we have a tangent, we have a secant line. See, this secant line, just like the slope of the line, it's just like a line. Do you get it now? Now on this line, just like the slope of the line here. Now on this line, or let's say on this curve, or on this function, we have 2 points. We have point A and we have point X. Are you there now? I want to use it to explain the concept of derivative. We have point A and we have point X. Now the slope of this line, now you see that I drew a line from here to here. Now the slope of this line from this point to this point, normally the slope of the line is changing y over changing x. And here this place is f of a, and this place is this place is f of x, and this place is f of a. That is changing y over change in x. So the slope of the line is changing y over change in x, which is m. Right there now. And also we can also say that this is the tangent. Because this is a tangent here, we can find the slope of the tangent also. Now how do we find the slope of the tangent? Now you remember that I say the slope of the tangent is also almost the same thing as the derivative. Now the slope of the tangent here at the given point here now is the slope of the tangent at a given point. Remember I said the slope of the tangent at a given point, but here we have 2 points. So what do? The slope of the tangent at this given point A, or let's say at the given point A, should be the limit at x tends to A of this function. What does it mean? That means that as x is going closer and closer and closer to a, then the slope of this tangent at this point is what? Is the limit as x is going closer and closer to a, is the slope of tangent of what? This what? Line. Is it clear now? So let me recap again. That is, as limit at x tends to a means that what? As x is moving closer to a, that is, f keep moving closer and keeps closer until you get to a, then what? A of what? The change of what? This line, that's f of x minus f of a over x minus a. I don't know, because if x move from here to this place, is still, I want to calculate the equation of the line. I want to calculate the slope of the line. We'll still use this. If x moves to this place, I want to calculate the slope of the line. We'll still use this function. If we move closer, we want to calculate the slope of the line. We'll still use this function. So as it is moving closer from here, maybe to another point here, to another point here, to another point here, to another point here, you see that this is the changes that is happening. This is the change that keeps happening as it keeps moving from one point to another point to another point to another point. Now, as it keep moving from each point till it get to a. That is the meaning of this. That is, as the limit of as x tends to a, that is, as x keep moving closer and closer to a, then we have this function keeps changing and keeps changing and keeps changing and keeps changing until it gets to a. Because when it gets to a, you see that what? You get 0, and definitely the slope will what? 0. That is, there's a relationship between what? The slope of the tangent and what? The slope of the line. Now, if the slope of the tangent is what? This. Now, remember I said that what? The derivative and the slope of the tangent are the same thing. Let's look at it. Derivative at a given point is equivalent to the slope of the tangent line. Let me recap. The derivative at a given point is equivalent to the slope of the tangent line. That is, the derivative here is the same thing as this slope of the tangent line. That is, this slope of this tangent line, this formula is still the same thing as what? The meaning of what? Derivative. That is, we can say that what? We know that derivative is what? The rate of change of its function at a given point. That is, the slope of the tangent of a line is also almost the same thing as what? The definition of derivative, and they also mean the exact. That is what I'm trying to say, that what? The derivative of f of x is also the same thing as what? The slope of tangent of what? Of a line, or the slope of a tangent line. That's why I say that this m here, which is the derivative now, will now be f prime of x will equal to what? This exact same formula. Do you understand? That is, the derivative of a function at some input is equal to the slope of the tangent of line at that point. Do you get it now? What he's saying that is just what I've been explaining again. That's what he's saying again. That is derivative of a function. This derivative of this function. Normally, for derivative, this is what you have been doing, which is the dy dx, changing y over changing x now, and this is just the general formula of representation. Do you get it now? Now, in case you are asked in exam, so now looking at this, you have the derivative of a function at some point is equal to the slope of tangent line at that point. That is, that what I've already explained, that is, the derivative is the same thing as the what? Slope of tangent at that same point. So at this point, the derivative at this point is same thing as the slope of tangent we got at this what? At this point. Is it clear now? So that is that about that. So as as x is increasing, so also, or as x is tending to a, so also the derivative is what? Just so also this one is also changing, and then we can easily get derivative when we get the slope of tangent. So that is, so majorly this is the formula for what? Derivative of a function f of x, that is dy dx, is the general formula for that. And also you can also use this in further calculation. So I think this is the end of this first lesson. In the next class we'll proceed further.